Okay, we're going to be on a second part of analyzing graphs of polynomial functions, which is starting on worksheet 18a. Yesterday, we looked at x-intercepts, we looked at relative maxes and mins, and today we're going to add in where the function or graph is increasing or decreasing as well. Identifying x-intercepts and turning points of a function, so the turning points will be the relative maxes and mins. Use a graphing calculator to graph the polynomial function. Identify any x-intercepts, relative maximums or relative minimums. Then identify intervals where the function is increasing and decreasing. They will be in x intervals. All right, so going on my grapher, as long as my computer will cooperate with me. Wasn't liking me having a calculator open with my smart notebook, which seems a bit ridiculous. Yeah. What's that? Yeah. All right, so 3x cubed is the first function, minus 9x plus 1. Oh dear, look what I did. I stayed up there in the exponent. I forgot to arrow out of my exponent. All right, there we go. It's real easy to do if you don't look at what you're typing. Okay, I'm going to zoom 6. Okay, and there's the graph. So I'd like to find the x-intercepts, of which there are 3. So I'm going to calculate all those. So second, trace, choice 2. Zeros. The first one is between 1 to -3 and -1. Tell it to guess by hitting enter a third time after you do your left and right boundaries, and you get the 0, -1.790. You need to write them as points. Do not just list them as a number. Okay, this next one, second trace, choice 2. That second one is a little bit more than 0, so I could put in 0 for the left bound and 1 for the right bound. It's between 0 and 1. And that one is at 0.110. And then our third one is between 1 and 3. Second trace, choice 2. Enter a left bound of 1. Enter a right bound of 3. Enter, enter. Not that those exact numbers, you don't have to match me exactly as long as you're to the left and to the right, but you're not too far to the left where you're, you've got 2 points in your bound. 1.670. Okay, it's had to go to the nearest hundredth. All right, so those are my 3 x-intercepts. Let's estimate those and get them on the graph because we're going to be sketching the graph. Now, they're very tight, close together. Okay, so I just stuck those dots on there. Now I'm going to find the maximum and the minimum. Second trace, choice 4 for maximum. And that thing's between -2 and 0. So I'm just putting in x values that it's between. Got a left bound and a right bound. I hit enter, and it'll jump right on top of there, which is actually at -1.7. -1.7, I'll plot the point. The minimum, second trace, choice 3. It's between, it's this little lower hump here. That will be your relative min, is where it curves right there. So that's going to be between 0 and 2. So I'm going to hit 0 for my left bound, enter, 2 for my right bound, enter, enter again. So it'll land on it. And it's at 1, -5, 0.9999. You understand why I'm rounding to 1, I hope, right? Okay, 1, -5. And then I will graph that. And now I can really tell what this graph's supposed to look like. It was coming from way down. It went through the first 0. It went up to that max. Oh, real quick, if I put in 0 into the function, the y-intercept is always a good thing to get. If you put 0 in, you get 1. So it crosses the y-axis at 0, 1. So you can get an even better picture. Goes through here, hits that real 0 that was really close to 0, comes down to the min, and then comes back up, and then shoots on up to infinity. Got a little extra dirt over here. There we go. All right, how exciting. Now, what does this increasing, decreasing stuff mean? Well, the graph is increasing, it's pointing down on the left. So what it's doing is it's going up, up, up until it hits its max, relative max. It then turns and goes down. That's decreasing. It gets to its min, and then it turns again, and it goes up, and it's increasing again. Make sense? Now, we're not going to look at y values, though. We're going to look at the x values or interval that it's increasing or decreasing on. So what that means is that from negative infinity on the x's up to, where does it hit? Right here. So let's think about this point. This point here was at negative 1, 7. Okay, so the graph is increasing along the x interval from negative infinity up to the x value of the max point, which is negative 1. You don't have to worry about inclusive or non-inclusive brackets. Let's use curved ones that are saying exclusive, because who's to say whether that max point is in the increasing interval or the decreasing, which we're about to write. Does that make sense? Now it's coming down. It's just the turning point. So now it turns and it starts going down. And the relative min was at 1, negative 5. Okay, so that'll help me think about this interval now. So from negative 1 to 1, it's decreasing. Make sense? From negative 1 to 1, between here, it's decreasing, coming down. The graph is coming down. Then it's turning and going up. So from positive 1 to infinity, it was increasing. You've got 2 points on which it's increasing. So we can put it together with that with a union, or you can just write and. Those are the intervals on which it is increasing. And it's decreasing on one little interval in the middle. Anybody still need this? It's time to try another one. Okay, negative 1, 4, up. This has got an x to the 4th, even degree. There's a negative x, a negative coefficient on the x to the 4th. So which way should it, what's the end behavior on it? Guys, you should know this without putting in the grapher for a second. Listen. I want you to think. You should know what it's going to look like. Okay, let's just, and you're good. You're saying the whole thing. So down, down. That's what I'm really thinking is, you know, it's going to point down, down. Okay, and no, but if I want you to write the end behavior, that's exactly how you would write it, Scott. Okay, so go, and then, so I'm expecting you to have down, down end behavior, and then it's going to do some kind of a hump or something in between there. Let's go ahead and put it in the grapher just like it was written. You can stick in negative 1 divided by 4, x to the 4th. Get out of the exponent, and then wasn't it plus 2x squared? And then that was it, wasn't it? Okay. All right, so I'm just going to hit graph. Oh, looks like the golden arches. McDonald's. You don't see a McDonald's sign? Sorry. Now let's go for the x-intercepts right away. Second, trace, trace 2. Now the first one we're going to see, where's it landed? Right there in the middle. 0, 0. Is that a 0? Looks like it's me. It's also the x-intercept. It's hitting at 0, 0. So I know that's the point on my graph. All right, but let's go find the other one. So I'm just going to quick jot that down though. Yeah, it's passing through 0, 0. And I think that's one of my x-intercepts. And actually, it's a double. Why would it be a double? Yay, because it bounces. Yes, there's a bounce. When a graph bounces, it's a double root. Okay, so I'm going to go back and finish calculating. So I had said second trace, and I want a left bound. 1, 2, 3, -3 will work, or -4 I'll stick in. Make sure I'm way to the left of that 0. And then -2 for maybe a right bound. Enter again. And I found out that's -2.83. -2.830 is a 0. 0, 0 is a 0. And I bet you guys are faster than me. So because I'm slow on this emulator. Isn't there one at +2.830? Okay, it has some beautiful symmetry. Right? What do I mean by symmetry? Same on two sides. It has a line of reflection down the middle, and that would be your y-axis, actually. All right, we need to find the maxes and etc. The min we got, 0, 0. Let's see what the max is. Second trace, the max of the first one on the left, choice 4, is between 1 to -3 and 0. Okay, and it's at -2.4. So I got a max at -2.4. I bet you there's a max at 2.4, isn't there? Would someone check? Yes, there is. Okay. And since I've done it before, I'm verifying for you that it is. Yes, ma'am. I'm just doing everything left to right. I just feel like if I keep on doing things left to right, some people get used to that pattern and they do everything left to right. It wouldn't be wrong, though, to be out of that order. Okay, so let's just sketch this thing. Did a bounce there in the middle. Oh, my arches aren't as pretty as on the calculator. No, that's terrible. Oh, well. Okay, so the min, where was it? Was that 0, 0, right? Now, did you try calculating that 0? Yeah, it's not going to be happy with you. It's going to say no sign change. So let me point something out. You see this guy? You see that -1/4 x to the 4th minus 2x squared? What could you factor out? Okay. Do you see that that is a double 0 now when you set that to 0? So I could even find out these zeros if I set those to 0. And this is what we're going to be doing in the next section, but not today. I'll just show you really fast that if I added 2 and then I multiply by -4, I get -8, right? Ew, those are not coming out nicely. Those are imaginary. So this isn't really it's an x-intercept, but it's a bounce. So is it really an x-intercept? Did that actually hit there? I'm going to try something because I'm just feeling like I might be a little bit wrong here. Hold on. Second trace value. I'm going to choose choice 1. I'm going to put in 0 for x and hit enter. Oh, I did get 0, 0. So it actually did hit at 0, 0. But this is a 4th power. This is to the 4th. Oh, Tom, hello. I just realized I did something mathematically stupid. Look, I already thought about it. Right here, guys, wasn't this +2? And I accidentally wrote a minus. Okay, so when I subtracted, I got negative. So when I did this, I got positive. I was going, wait a minute. I'm supposed to have 4 real zeros, a double 0. And then this would give me my plus or minus the square root of 8, which would be plus or minus 2 root 2. Guess if you type 2 root 2 in, you're going to get 2.83 and negative 2.83. Those are these two. Okay, these are the ones representing those 2 zeros. All right, anyway, so we're good. All right, what happens? Well, I'll find out more. I got more to tell you on another day. Oh, my word. I didn't finish that problem. Okay, increasing from here to here. Negative infinity to where? What's that top point? It was at negative 2, okay. All right, and then it's all decreasing after that from negative 2 to 0. And then it's increasing again from 0 to 2. So I'll go back to my increasing part. Union. And then it starts going down again. So from 2 to infinity, it's decreasing. No. I'm talking about x's. From 2, an x value of 2 to infinity, it's decreasing. The graph is decreasing. I am not, all right, this is not the same as M behavior. I'm talking about x intervals. So that's why I'm going to these x points. This was negative 2, 4. This was positive 2, 4, right? We're going from negative infinity to negative 2. The graph is increasing. Okay, I'll say it again. Okay, you're feeling it better now? From negative 2 to 0, it's decreasing. And on the x interval from 0 to 2, it's increasing. And on the x interval from 2 to infinity, it's decreasing. Okay? Try another one. Well, you know what? I can't resist to speed things up instead of the graph. A grapher gets me crazy sometimes. I can get the relative max and min real easy, but I want to show you something real quick. What if you factored this? What's the common factor to all of those guys? So that gives me x squared minus 5x. Oh, is that, what power is that? Oh, gross. Never mind. I don't know. I'm going to try it though. X times x to the 4th minus 5x. Is that a cubic in the middle? Squared plus 4? Okay. And let me see what happens if I factor that again. You guys can go type it in your calculator while I mess with this. Yes, Scott. Your calculator what? Oh, yeah, go plug it in. Sure. Okay, so now you guys are graphing, and I'm going, because I'm hinting into the next section that we're going to do on Friday. We're having our quiz on Thursday, quiz 9. Okay. Tonight, your assignment's going to be worksheet 13 and 14. Okay, the x-intercepts. Let me ask you this. Do you see 0, 0? Do you see negative 2, 0? And then the next one's 0, 0. No, I bet it's smaller than that. All right, you probably have another one. Okay, I'll just tell you what I think some of them are. And then what's the square root of 1? Somebody do square root of 1 for me as a decimal. Yeah, because you guys are going to get decimals. Oh, what's the square root of 1? Oh, my Lord, I can't believe I just said that. I have chewed out more students than not chewed out, but I've said something like, you guys, can you not simplify the square root of 1? Sorry, I can't believe I just did that. Plus or minus 1. So you should have negative 1, 0, and 1, 0. Are all those zeros that you're seeing? Okay, let's plot them. Oh my gosh, I can't believe I said, what's the square root of negative 1? Oh my word. All right. Oh, it's called. Wow, that was a good one, Heimer. You should delete that out of your recording. No, actually, I should leave it to say, oops, sorry, I'm only human. All right, there's a lot of squiggly stuff going on in between there, isn't there? And the first one, though, it's coming from down, right? Okay, so the next thing what we want to find is we want to find that maximum. You guys go find it. Will you find that first maximum hump, please? This is the part I hate. All right, no, I'm kidding. It's a lot of stuff. You should be, if we're getting it right, negative 1.64, 3.63. Yes? Okay, 3 points, almost to 4. Oh, gross. All right, and then it twists and comes back down. It goes through negative 1. Okay. Do you want me to put it on the grapher and show you how I'm getting all these numbers? All right, you guys keep going and then we'll verify. Okay, the next minimum, the first minimum should be at negative 0.54, negative 1.42. And that's not going down too far. So right around here, and then it came back up. And the next max is at 0.54, 1.42. So kind of like emulates the previous min. So it comes up here, and then it comes back down. And then the next min is at 1.64, negative 3.63. So it's just like that max, except the signs are changed. So it's like around here. So then it did a loop, and then it went up, 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 away. Okay, increasing, decreasing. From negative infinity to the first x value of the max. Negative infinity to infinity up to negative 1.64. That's the first increasing interval. Use this point right here. Okay. Another one. All right, then it's decreasing. So I'll go down here and write that from negative 1.64 and then down to the first min, which was at x value of negative 0.54. Okay, then it increases. So we'll go back up here, negative 0.54 to the next max, which was the next value of 0.54. We okay? Yeah, but you can, or and, union is fine. Then from 0.54, it comes down, decreasing until it hits the second relative min, which is at an x of 1.64. And finally, it increases from 1.64 to infinity. No, me either. There's too many decimals. A lot of decimals. No, the decimals get confusing. If it was a lot of whole numbers, this would have been less painful. Okay, I actually skipped the second period. I had to do it twice. Whoops, never mind. Okay, anyway, number 4. I did it for the video. All right, ready, set. This one says 1/5 x. Oh, looky, it's already in factored form. How special. That's nice. Since this is in factored form, we can easily identify the zeros. They are 2, 0, negative 1, 0, and negative 3, 0. Those are your x-intercepts. I'm bored with red, so I'm going to plot them with, oh, that's not even the right one. Okay, 2, 0, negative 1, and negative 3. All right, then we can use the graphing calculator to find any turning points. All right, so let's do it. 1 divided by 5, x to the third, oopsie. I don't know. I forgot it was factored. But I know what power would it be if I had to multiply it out? Please. What is the highest degree of this polynomial? What degree is the polynomial? Now, it's x times, aren't there 3x intercepts? It's x times x cubed. Okay? You should be able to identify that. Oh, darn it, I did it again. Parenthesis, hello. And what was the first one? X. Thank you. It'll speed me up a little bit. I don't have to look over at my binder. Thank you. X plus 1. X plus 3. Thanks. I should have been able to remember that since I know the zeros. Okay. Bingo. Oh, not very humpy. I mean, kind of smooth. Well, that was kind of a weird term. Maybe I should put pause on for a long time. Okay, second trace. Humpy. Oh my goodness. Trace 4. All right, I'm going to calculate my max here. Between -3 and -1 or whatever. Remember, just as long as you've got some decent numbers, it doesn't have to match what I'm putting in. All right, -2.12.81. Okay. So I found, oh, -2. Was it 82? 12. And then 0.81. That was this lovely bump right here. It doesn't even do much of a bump. Okay. And then what's the y-intercept? So let's put a 0 in here. If you put a 0 in, you'll have 0 minus 2, -2. If you put in 0 in the second one, you get 1. If you put in 0 in the third one, you get 3. So that's -6/5. Lovely. 0, -6/5 is your y-intercept, which is just a little below -1 on the y-axis. And then, did that thing twist back up from there? And went right through there? Like that? I forgot. I gotta check for a relative min though, don't I? I think I made my hump not, it needs to come more down, doesn't it? All right. Okay, well this is just, good enough. All right, try to be as close as you can, but not perfection. All right, so we're going to get that min, and that would be second trace, and you guys are probably done by now, and I'm still doing it. All right, okay, from 0, enter, to 2. You're still doing it, Natalie? Oh, guess. Oh, -0.79, -1.64. Okay. Close. What do you think the little squared thingy does? Ooh, 2 of them are squared. That's a double root. And this one is it squared also? I can't even see from here. Yep, it is. So it's a double root. What's a double root cause? Bounce. Okay. Bounces. Yes. All right. So what are these zeros? The graph bounces off the x-axis at the points 3, 0, and -1, 0. All right, it has a positive leading coefficient, and squared times squared is a 4th power, so it's an up-end behavior because it's an even root. So it should do this. It's going to bounce from there, and then what's the y-intercept? If you put in 0, you get 1/2 of 3 squared times 1 squared. Okay, that's half of 9. 0, 4.5, right? Okay, so it bounces here, goes through, and then it's going to come up here somewhere, and I got to find that relative max. We got to go back to that graphing calculator, and I got to put it in. What lunch do you have? Scott, what lunch do you have? I have that first lunch. I have brunch. I heard you say you're hungry.
Oh, no, I said that.
Oh, I thought you said I'm so hungry. Yeah, what lunch do you have, Scott? I thought he said he's hungry. Oh my gosh, that's funny. Okay, well, our golden arches shifted a little bit, didn't they? All right, let's find that relative max, please. Second, Trace. Okay, I digress. If I can't get you back, then I'll quit doing it. 0, enter, 2, enter. All right, now I got 1, 3.2. Okay, let's sketch that. Oh, well then, I don't get what I did wrong. I thought that's 9. Yeah, half of, well, this is only 1. No, the x-intercept is fine. 4.5 is fine. I just didn't get the right, you know what I didn't do? I didn't put in the right graphing thing, did I? What is this point here? Is it 1, 8? Yeah, because that's what I wrote down in my notes when I did it. I got a max of 1, 8 when I did it. So I'm not even going to bring mine up anymore because I need to hurry up and finish. All right, 1, 8, you guys are getting it. And then it went back down, and it bounced here again and went back up. All right, what minimum do we have? The minimums would be 3, 0, and they'd be our x-intercepts, and -1, 0. Okay, over and out. What's assigned is the quiz preview and worksheet 13, which is practice graph with factoring.